Hello everyone and welcome back to Level Up STEM for our Calc 1 practice problem series. We're on the fourth video and make sure to like and subscribe. For our first problem, we have a graph given, g of x, and we have the following characteristics about this graph. We have a vertical asymptote at x equals 2, so that would be this right here, and a horizontal asymptote at y equals -3. G of x is continuous and increasing on the interval -infinity to 0 up until there. And g of x is continuous and decreasing on the interval 2 to infinity, so that's there. And the tangent line to the graph of g of x at x equals 0 is horizontal. So that would be this tangent line here is horizontal. All right. We have some true and false here. So consider g prime of x the derivative of g of x and determine whether each statement is true or false. Okay, so let's break these down one by one. So in this first problem, we have g prime of -4 is equal to 0. Well, that would be false. G prime of -4 would be a positive number. As you can see here, it's going up. There's a positive slope, and it's a positive number due to positive slope. For the second one, we have g prime of 0 equals to 0. Well, that would be true, because g of 0 is a maximum value. So we have, again, with that, and that tangent line there is a 0 slope, so the maximum value would have a 0 slope. The third one, g prime of 3 is less than g prime of 6. So that means g prime of 3 right here is less than g prime of 6. So comparing that slope. And that would be true since g of 3 has a steep negative slope compared to g of 6, which isn't quite as negative of a slope. And for our fourth question, we have g prime of -4 equals g prime of 4. So that's this slope right here compared to this slope. Well, we know that's not right because those are, one's positive and one's a negative, right? Yep, that'd be a false answer for the reason I just said. Okay, I think it's the last one for this one. G prime of x is decreasing on the interval -2 to 1. So we have, right, it's starting out right here as a positive slope, and then it goes to 0 right there, and then eventually negatives right here. So it goes from positive to 0 to negative, so I think that would be decreasing, right? Yep, that'd be true, and for the reasons I just explained. Okay. Now for the second portion of this problem, we have considered this function, h of x equals 3g x plus 2 in the parentheses, and we have some more true and false to answer, so let's get into it. So we have this h of x equation again, and h of x is defined for all real numbers. Well, this one would be, yep, true. Since every x value is defined on this graph, there's no undefined values of x. And a counterexample of this would be if there was a hole at x equals 2. So if that was a hole right there instead of a filled-in point, that wouldn't be continuous, or it wouldn't be defined actually at x equals 2. So when you put x equals 2 into this equation right here, you would get a undefined answer for h of x, right? The second one, the line y equals -1, is a horizontal asymptote of the graph of y equals h of x. So this one's actually false because that 3 factor in front of g actually stretches it horizontally. I know some people might think that, well, this is at -3 right here, so wouldn't that just shift up by a value of 3? And it's actually multiplied by a value of 3, right? So that wouldn't be, just 3 square units. It would be, I guess, 9 in this case, because it's multiplied by that 3. So that would be false on that one. And we have the line x equals 4 is a vertical asymptote of the graph of y equals h of x. And again, this is also false. It's a little tricky. When it's a positive inside the parentheses, that means that it actually shifts to the left, not to the right. I know it's a little counterintuitive, but it would actually shift to the left in this case. So x equals 0 would be our vertical asymptote on that new graph. And we have h of x is not continuous at x equals 0. And that'd be true since that asymptote that would shift to the left would actually be at x equals 0 now, and that would be continuous at x equals 0. All right, make sure you like and subscribe, and I'll see you guys in the next video. Peace.